Simplifying complex fractions. Made easy. Example number 1. We want to simplify this complex fraction. What we need to do first is we need to find the least common denominator, or the LCD. The numbers we need to find the LCD for is every single denominator in each fraction. So we have a 3, we have another 3, and we have a 4. So that means we want to find the LCD between 3 and 4. The way we find the LCD is by just finding the multiples of each of these, and whenever they have a number that's the same, then we can stop. So looking at 3 here, let's go ahead and do the multiples. So there's 3, 6, 9, and 12. And for the 4, it goes 4, 8, and then 12. Since they both have a 12, we can go ahead and stop. That's going to be our LCD. So LCD is equal to 12. Now what we do with this LCD is we multiply every single number by that number. So basically we're going to multiply this entire top part by 12 and this entire bottom part by 12 as well. Like that. And the reason why we can do this is because 12 over 12 is just 1, and you can multiply anything by 1 and not change it. So now let's go ahead and continue this. Looking at the top fraction, we're going to multiply 12 times 1 plus 12 times 4 over 3 divided by, now let's go ahead and distribute the 12 over there too. We have 12 times 2 over 3 plus 12 times 11 over 4. From here, we just continue to simplify. So the top one, 12 times 1 is just 12, plus 4/3 times 12. Well, what we can do is simplify this fraction now. This is going to cross out, become a 1, and this 12 is going to cross and become a 4. So now we just have 4 times 4, which is 16. Now, looking at the bottom, this 3 is going to cancel out, become a 1. This will become a 4. So now we have 4 times 2, which is 8, plus, looking at the next one, we have 4 here, so that's going to cancel with the 12. And that's going to become a 3, so we have 3 times 11, which is 33. Now, as you can see here, we just have a simple fraction that we can simplify. That was the whole point of finding the LCD, is so we can eliminate the denominators from the other fractions. So 12 plus 16 is going to give us 28, and 8 plus 33 is going to give us 41. Since we can't simplify any further, this is going to be our final answer. Example number 2, we want to simplify this complex fraction here. Now, it's the same concept as before. We want to find the LCD. So we look at our denominators. What we have is an x squared, and we have an x. So I'm going to list x and x squared. Whenever you're dealing with variables, what you're going to do for your LCD is pretty much just keep the largest one. Like that. So our LCD is actually just going to be x squared. What we do from here is the same. We're going to multiply the top and the bottom by x squared. Like that. So let's go ahead and multiply this. Looking at the first one, we have x squared times 1 minus x squared times 9 over x squared. And on the bottom, what we're going to have is x squared times 1 plus x squared times 3 over x. Now what we can do is just simplify. So x squared times 1 is going to be x squared minus this x squared is going to cancel with this x squared, so all we have left over is a 9. And on the bottom we have x squared plus this is going to cancel out right here, and then we're only going to have 1x left, so it's going to be x squared plus 3x. Now we can factor these. So the top is going to be x minus 3 times x plus 3. And on the bottom, we can factor out an x. So we'll have x times x plus 3. And we see here we can simplify further by canceling out the x plus 3 here and the x plus 3 here. Now all we do is just write down what's left over. I'm going to write this on the left-hand side. What we have left over is x minus 3 over x. And that's going to be our final answer. Example number 3. We want to simplify this complex fraction. What we're going to do first is find the LCD. What we do is we take each denominator. So we have an x, we have a 6, we have a 36, and we have an x squared. So I'm going to write the numbers next to each other, and then the variables next to each other. And the same concept applies. Now we just have to deal with both of them at the same time. So for the numbers, what we do is we find the multiples of each one, and when they come up to a number that is similar, we stop. So for 6, we got 6, 12, 18, 24, 30, 36. So we can see that 36 is going to be the LCD for the numbers. And for our variables, we have an x and we have an x squared. So we're going to take the large one right here. Now what we do is we combine them. So we know that 36 is the LCD for the numbers, so we have 36. And then for the variables, we have x squared. So we're going to multiply the top and bottom by this LCD right here. So let's go ahead and do that. So we're going to multiply the numerator by 36 x squared to each number in there, and the bottom as well, 36 x squared. Now let's go ahead and distribute. The top fraction is going to be 36 x squared times 1 over 6 plus 36 x squared times 1 over x divided by 36 x squared over 1 over 36 minus 36 x squared times 1 over x squared, like that. Let me delete some of these so it's not in our way. Okay, so now we just go ahead and simplify. Looking at the top, this is going to become a 6 and this is going to cancel. So what we have left is 6x squared. Looking at the second one, 1x is going to cancel. So we're going to have plus 36x. Now we look at the denominator. We have 36 and this 36 are going to cancel. So we just have an x squared. And then the second number, x squared and x squared cancel. So we just have minus 36. All right, so now what we can do is simplify some more. In the numerator, I can factor out a 6x, and what we'll have left over is x plus 6. And the denominator, we can factor that as well, which will be x minus 6 and x plus 6. Now we can cancel the two x plus 6 terms like that, and we're going to write down what's left over on the left hand side here. We have 6x over x minus 6. We can't simplify any further, therefore this is going to be our final answer. Example number 4. We want to simplify this complex fraction here. We begin as normal finding the LCD. And whenever we do that, we look at each denominator here. So we have x plus 1, x plus 2, x plus 1, and x plus 2. However, in this case, we can't just simply look at each one of these separately. Like we can't look at the 1s and 2s as separate numbers and the x's as separate variables. They have to come together. So you can think of them as having a parenthesis around them, treating them kind of similar to a binomial, like that. So whenever this is the case, where your fractions have, I guess, more than one term, like an x plus a number, what you do to find the LCD is simply write down each one that's different. In this case, we have x plus 1 as one of them, and then the other one is x plus 2. Those are the only two different kind of binomials we have. So therefore, our LCD is going to be this entire thing, x plus 1 times x plus 2. From here, we continue as normal. So we're going to multiply the top by x plus 1 and x plus 2. And then we multiply the bottom as well by the same thing, x plus 1 and x plus 2. To save some time, what we can do is, we already know that we're going to be canceling these fractions out. So let's look at the 3 over x plus 1. We know that we're going to be multiplying that by x plus 1 times x plus 2. We can see which one's already going to cancel. So we know that this x plus 1 is going to cancel with this x plus 1. And the only thing that's left over is this x plus 2 here, which is going to be multiplied to the 3. So to save a step, instead of distributing out everything, we're going to cancel from here and write down what's left over. So for this first fraction, 3 over x plus 1, when we multiply, that's going to be 3 times x plus 2. Like that. Now, let's look at 2 over x plus 2. We can see here that this x plus 2 is going to cancel with this x plus 2, and what's left over is this x plus 1. So let's go ahead and multiply those together. We're going to have negative 2 times x plus 1, like that. So now the numerator is complete. That's going to be divided by, we do the same thing on the bottom. Looking at x over x plus 2, we can see that the x plus 2 is going to cancel with this one. And what we have left over is x plus 1. So we multiply x times x plus 1. Looking at the next fraction, we have 6 over x plus 1. So this is going to cancel with this. And what we have left over is this x plus 2. So that's going to be plus 6 times x plus 2. So now we have this large fraction here. What we do is we distribute. So we're going to distribute the 3 into each number here, and so on and so forth with every number. So let's start with the numerator. Distributing the 3, we're going to have 3x plus 6. And now we distribute the negative 2. We'll have negative 2x minus 2 divided by, now we distribute the x. X times x is x squared plus x plus, now we look at the 6. We got 6x plus 12. From here, we can go ahead and combine like terms. So at the top, we have 3x minus 2x, which is just x. And then we have 6 minus 2, which is positive 4. And that's going to be divided by x squared. There's nothing to combine with, so we're just going to write down x squared. X plus 6x is 7x, so x squared plus 7x plus 12. And now when we're looking at this, we can see that we can actually factor the bottom now. So the top is going to stay the same at x plus 4. And the bottom is going to be x plus 4 times x plus 3. What do we see here? we can cancel the x plus 4 that's on the top with the x plus 4 that's on the bottom. Now, you might be thinking there's nothing in the numerator, however, there's still a 1 there. So therefore, on the left-hand side, our answer is going to be 1 over x plus 3. And this example is complete.